vibration and museum exhibit.
Not my wording of the title, I have to say, but thank you, Lucy. So as a conservator, we think of lots of ways of preserving. How can we preserve the collections? But actually, we also spend quite a lot of time thinking about how can collections get damaged. And a lot of traditional sort of approaches have been looking at light and humidity and temperature. But one area which really hasn't been looked in very much at all is vibration. And this OUMP Innovation Fund project has given us a chance to get the equipment and make a start at addressing that. So the project aims was to set up a network for this equipment to be able to start working. And I should have guessed with the innovation that it would actually be quite difficult to get it to work. So it's been about a year trying to get it, all the equipment, the sensitive equipment, up and running. It's been Manolis, Chatzis, and his DPhil student, Maria, who have been leading on that. And they've done a fantastic job. It's been a really good collaboration opportunity with the Department of Engineering Science. So museums mostly think about vibration when it's a building project. And building project, well, demolition, that's usually when the vibration comes in. On the left, you can see early phases of demolition ahead of the Ashmolean redevelopment project, and the British Museum on the right. And you can see the sorts of things that can cause vibrations. But it's also internal as well. There's quite a lot of gallery refurb, building work inside. And here we have the Egypt Galleries project, which was 5 galleries refurbishing, but also quite a lot of demolition and redevelopment too. So a lot of sources of vibration there as well. Here is a case that was against the wall, the back wall of the Ashmolean, when we did some trials of Kango work behind, breaking out a concrete crane pad. I think you can see the swiveling. So vibration there has ended up in a swiveling motion. I don't know if you get a chance to look up the Manchester Egyptian statue that was had time lapse on it, and it swiveled during the day, and that's something that some objects tend to do with vibration. But what's the risk to the collection? Well, that could fall off the front of the shelf, it could collide with other objects in there. It could also suffer from a sort of a fatigue damage from constant vibration, which is deforming, it's stressing the object in different ways. Surfaces can fall off. And a bit like bending a paper clip, you know, suddenly it'll go, and you just don't know. That's the theory anyway. And actually it can be catastrophic. So this is a case that was against the Beaumont Street wall. It's an old case. It was a poorly fitting shelf, where we think it was vibration, possibly from buses outside, constantly against that wall. And that was fairly catastrophic. We don't have those cases anymore, of course. So the Egypt project, we approached monitoring by going to a consultancy, Bickerdite Allen, and we did a trial run. So we had sensors fitted around the building. The Egypt Gallery is sort of nestled at the centre of the museum. So it has a painting store below, it has a store for cuneiform tablets above, it's got Western art galleries above. We couldn't empty the whole lot out, but we knew there was going to be a lot of heavy building demolition work going on. And so we monitored various bits of demolition kit, and not surprisingly, we found like a cutting piece of equipment was the way of demolishing the wall rather than percussion. And we also had real-time alerts. So if the builders were starting off early in the day, we were thinking they would get some major demolition going, we knew straight away. So it's about communication there. And I think this model has happened at the British Museum and at the Met, other places that have had this sort of work. But what happens when the museum's just normally running? That's something people really haven't looked at all. And that's something that we wanted to address with this innovation project. You know, what does footfall do? Well, when we did trials for the Egyptian Galleries project, we found that you know, a party of a school party going past a case actually caused more vibration than the jackhammer that was 2 floors below. So, you know, what do we do? What do we do about that? Also, music. I mean, museums are used more and more for events. Is a harpsichord sort of recital any different from a rock concert in a museum? What's the impact of that? And people really haven't measured that before. So what we decided to do was use the Live Friday events, which are absolutely fantastic. There's heaps going on. There's events, there's dancing, there's music, there's theatre. And a lot of people, so it's often sold out. It's really, really good. And we chose 2 sensor sites. One sensor was bought by the project, and the other parallel sensor was bought by the Department of Engineering Science. One on the ground floor and one on the first floor in the Islamic Middle East Gallery. And we thought that was good because it overlooks the atrium, people gather around it, it might catch some of the footfall. The equipment is highly sensitive, so if you have a concert playing, it records that in terms of vibration, but you can actually play the concert back again. And what was quite tricky was getting that working plus a wireless network within the building to record it. And what we found was the hour before the event was fine, we had good readings, and then everyone came into the event and started using the Wi-Fi, and then we lost signal. So. And here is a case wired up. There's XYZ orientation for the sensors, and then underneath in the technical compartment you can see the wires. I mean, these are 50 meters of wire, so we've got the chance to wire across the gallery. You know, we can use it all sorts of places, which would be good in the future. So we've recorded 2 Live Friday events. What we've found is using sort of thresholds for damage from the construction research, we had 3 alerts during one of the Live Fridays. One was, we think somebody bumped into the case. One we don't know, and the other one was because of testing out a synthesizer, which we asked them to do. And we were looking at the different sources and whether that made a difference. And actually it turns out that synthesizers, the particular sound waves that a synthesizer makes, is potentially quite risky. And so what we asked them to do, or what Manolis asked them to do, was, can you play a C0? That's 3 octaves, I think, below middle C. And that's very low frequency, and low frequency is not good. And they said, yeah, we can do an octave below that. So they did an octave C minus 1. And that was, we were all kind of shaking at that point. You know, just stop that at once. So if we're going to ban a note across the museums, let's ban C minus 1. Okay. But this is just really the start for us. And I think once now the equipment is up and running, we can use it for all sorts of testing lots of different questions. We can extend it to other cases in the building. Is it a bouncy floor a real problem? We have a couple of galleries with quite bouncy floors. Is the vibration going through the back of the case more and into the shelves? Is it a problem looking at different sorts of music? Is a rock concert actually going to be a problem? Or is it not really an issue? And then different sorts of ways of mitigating vibration. Sorbethane is commonly used, so we'd like to test that out as well. This is just an example of what we've done in the meantime. So this is the Welby Gallery. And here's some mounts with pegs to stop travel. So we're anticipating that may well be a problem, and we're securing the objects. This is something we'd like to do. We send our collections away, and we really don't know what happens in terms of the vibration as it's travelling. And these are some of our most valuable pieces in the collection. So finally, I'd just like to thank Manolis and Maria for their help setting it up, and Francesca, Paul and Anjanesh for their patience and help in the museum, and finally to the Innovation Fund for helping us buy the kit and the start of a really good research project.